Okay, everyone, we are going to look at going from a situation to the graph and equation of a sinusoid. So for our example here, I found some information about the Seattle Ferris wheel, and I learned that its height is 175 feet. Its one ride is 3 revolutions in 12 minutes, and it cost $20 million to build. What I didn't find was how high the bottom of it is off the ground, so I just made that up and said it's 9 feet. So we're going to graph the function of height versus time if you were at the top of the wheel 1.5 minutes after getting on the ride. I know that doesn't actually jive with the real situation, but I didn't want to have the top or bottom or middle to be on the y-axis. So fake it. So we're going to graph it and write an equation. Some people write the equation first and then graph it. I graph it first because that's just the way my mind works. So when I look at this and I'm like, okay, the information I have is that the bottom is 9 feet off the ground, so I can call that 9 feet. The top is 175 feet off the ground, which means the middle is halfway between those two, which you can get by averaging out the top and the bottom. So the middle of this guy is at the 92 foot mark. And I can draw a little line there. And then the one thing we know is that we were at the top of the wheel 1.5 minutes after getting on the ride. So I'm just going to plot that here and call this 1.5. This isn't exactly drawn to scale, it's just drawn close enough. And then if it's 3 revolutions in 12 minutes, that tells me that the period is 4 minutes. So that means at 5.5 minutes, I'm going to slide up here, at 5.5 minutes, I'm back to the top. And then it makes sense that 2 minutes after I'm at the top, I'm at the bottom. So 2 minutes after 1.5 is 3.5. I like to have those 3 points because then it kind of gives me enough that I can sort of check my work, and it also gives me enough to draw a fairly bad sinusoid. So in order to find the equation, if we have y equals c plus a cosine b x minus d, that could be sine obviously as well. I like cosine better since cosine starts at the top and I can find the top easily. But we need to figure out the a, b, c, and d parts. So c being our sinusoidal axis, that's the middle. So in our case, 92. The a is our amplitude, which is this distance here, and that is 83 feet. The b we find using the period, because 2 pi over the period is our b. So in this case, 2 pi over 4, which is pi over 2. And then finally, our phase displacement is that horizontal translation, and I'm going to call that the 1.5 from where we knew we were at the top. So now we can write our equation. We have y equals 92 plus 83 cosine pi over 2 x minus 1.5. Once you've graphed or written your equation, you want to graph this on your calculator and compare it to what you've drawn, because that's going to verify you've done everything correctly. So in my y equals, I have my equation put in here. I'm going to annoy people by not closing my parentheses. Doesn't really matter. What does matter is not closing the parenthesis after the pi over 2, because if you do that, you'll do cosine of pi over 2, you'll take a deep breath and multiply it by x minus 1.5. Setting our window, it makes sense to make the window just match what we see here. So I'm going to go 0 to 6, or even that 6.6 is fine. For my min and max, I'm going to do 0 to 200. And for a y scale, it honestly doesn't matter what you make your y scale. You could make it 0, and that way it won't draw anything in at all. I could put 25 in or something like that, but it doesn't really matter. This slowly will draw itself, and then once we've drawn the graph on our calculator, we can verify things working by hitting trace. And I know 1.5, I should be at the top at 175, and if I do that, 1.5, 175. At 3.5, I should be at the bottom, and I am at 9. And then 5.5, I should be at the top, and I am. So it's a good idea to verify by graphing, and remember, you can set your window based on what you've drawn. So there is our example of writing a sinusoid and making a graph for a real sort of fake story problem type thing.